Hello, my name is Ndozo Shabani. Welcome to my YouTube channel. Today, guys, we are going to design PCB layout on Proteus. So, I designed this PCB just now, and I used like few electronic components just to make it simple. So, we are going to do the same process, and so we're going to do it step by step. So the first thing that you need to do, sorry about that. The first thing that you need to do to get to this step, you must first have Proteus. So I have my Proteus here. Let me open Proteus. You must have the software called Proteus. My computer is very slow, so definitely this is going to take a while to open. But let's give it some time. Or maybe we can just take a shortcut, open new project. Yeah, save. I'm going to save. And while waiting, there you go. So now this is where we are. So when you open Proteus, it takes you to this page. So it's a home page. So what you need to do to a home page, remember, if you encounter any problems or difficulty, remember to come back to get help here, and then this is PCB layout, and then this is where you're gonna get all the answers about how to design PCB layouts on this software. But if you're not having any problem, then it's okay, you can continue. So now we are not going to go straight up here into a schematic capture, because we are going to design something that's going to need a PCB layout, and I use a microcontroller, which means we're going to also need a firmware. So now what we're going to do is to open a new project. Click open new project and give it a name. I'm going to say it's going to be PCB layout. First time. We all doing this for the first time, right? So I'm going to say first time. That's the name for the project. And the new project, yes, we are developing from a previous board, but it's a new project. Then click next. Now, do not create a schematic. Create a schematic. Of course, we need to create a schematic. We're going to select a template, and then now choose default. For now, continue. Do not create a PCB layout. Nope, we want to create a PCB layout. So that's the reason why we're doing this lesson, because we want to create a PCB layout. So now all these are PCB layout designs. So you just have to choose the default, so that you're going to have like a double layer PCB layout. That's the default. It's just double layer PCB layout. So we have a top layer and then the bottom layer. On the top layer we have the top resistor and then the copper, and then at the bottom we have the bottom resist and the copper inside, right? So for now we are going to design this PCB layout with just like two layers. They are like this. This is like, there's no need to change any of these. And here I don't think we have to change, like make one, just everything, just leave everything like this. Click next, and then yes, this is how it's supposed to be. So this is the PCB board preview. This is how it's going to look like. And then click next. Now come here, because we want to design our project. We are going to design a PCB layout for a PIC microcontroller. So now click on create firmware project, and then now go choose. I'm going to choose PIC 18. You can choose any PIC that you're going to use, any microcontroller that you're going to use, and then I'm going to choose and click on 458, because it's the one that I know how to program and how to configure. I'm sorry about that. So now, and then you come to the compiler. The compiler is going to choose MPLAB C18, right? So you must make sure that the compiler, you download the compiler if you don't have it. If you have the compiler, then it's okay. So I do not have the compiler. If you don't have the compiler, go to the compilers, and then you search for the one that you want. Where is it? PIC 18. Nope, not this one. High tech, just this one. MPLab 18, go to the site and then download the compiler, and then you have the compiler installed here. Once the compiler is installed, it's gonna be easy for you to run all the projects or design any project and then compile the code on this microcontroller. So on any program that I'm going to design here, it won't run, it won't work. So I'm here just to do a schematic capture, not to run the program. Next. Then everything is good. Next. Now it's going to take you to the schematic and then to the firmware. So the firmware is where you design. This is where you're going to put the code. This is where you're going to decide whether you're gonna have input as port B or output as port B whatsoever. This is where you put your program and then you run the program right here. So for me, there's no need for that, right? I'm not going to put the program here. You are going to put the program here and then you're going to run the program. Make sure the compiler is installed. So I'm not going to focus on this page, but this is where you're going to write your program. So if you want to toggle the output or anything, if you want to turn on the lights using the switch, your program is going to be written here, and then your schematic is going to be designed somewhere here, right? We design a schematic, we have a schematic, we design a schematic, and then the PCB layout is going to be right here. So now the first thing we need to have the schematic circuit diagram. Well, I already have it, so I'm not going to design it from the sketch. I'm going to paste it somewhere here because I already have it. So this is the circuit that I have. So let me zoom in a little bit. Good. So I used PIC 18 F458, and then here there was a bulb, and then here there was a switch. So now the reason we put these connectors replacing the switch and the bulb is because the bulb does not have the PCB package. When something does not have the PCB package, you can either download the PCB package if there is it, and if there is no PCB package for that component, you have to replace the component with the connectors. We have the connectors to the component so that when you have the PCB layer designed and printed out, you can just go connect your component into the connectors, right? So this is the connector one for the switch, and this is the connector, second connector for the bulb. So there was a bulb here and there was a switch, right? So the rest, all these components, they have PCB packages, so that's fine. So if you find something that says there is no PCB package for this component, just replace it with the connector, depending on how many pins it has. So if it has 2 pins, then you're gonna choose this one with 2 pins. If it has 3 pins, choose the connectors with 3 pins. So where you get your connectors, you go to P and then type connectors, or maybe just scroll down, you're gonna find them here somewhere. There are connectors there, and then all these are connectors. All these, just choose the one that you want. All these are connectors. Now we are done with the circuit. Once you have the circuit, like it's complete, and you can go to the source code. You put your code here and then you run, make sure it's running, and then you come and check on the schematic capture. While you run the code, you need to have your bulb and your switch here, so then you can simulate and then see if the program is working properly. Once you find out that the program is working properly and the circuit is perfect, there is no mistake, then you replace the switch and the bulb with the connectors, then you go straight to the PCB layout. Now we're in the PCB layout. We need to get all those components on the schematic capture and then bring them into the PCB layout and design the PCB layout. The first thing that you need to do is to create the border. You must have a border. So you go straight here. This is where you draw. These are the graphics, and then you just want to create a box or a circle, depends on what shape you want your board to be. So I want my board to be, I want my circuit board to be a a square. I think that should be enough. I think that should be enough square, right? And then this line you can like center it somewhere. If you want to put it into a center, this is say want this to be the center. That's going to start there, and there's now right in the center. So if you want your box to be right in the center, you go click center right here, and then go click on the corner, the right corner, and then click on it. Then it's going to be straight into the center. Great. So now what we need to do, remember I told you in a previous tutorial that you need to pay attention on your left hand side, because this is where everything is going on. So now this is the pointer, and then this is your component. Go to the component, you have all these components here. You can take component one by one, click on it, and come place it here. Go click another one, come place it there, or whatsoever, right? But if you want to, you can just go to tools instead, and then go to auto place, and then your components are going to be placed there automatically. Then auto placer. Well, it says there is no space, so the border is too small for all these components to fit in there, right? I think I've made a mistake somewhere here. I'm supposed to replace this. Oh, it's already replaced, but we have to replace nothing. So okay, so I just have to make it a little bit larger, so that the what's that? So that I'm gonna make it to the center. Click onto the center there, and then come here. Great. Make that one on the center. Great. So that all the components will start placing from the center. Now I can go and say tools, auto placer, and let's see. Okay, what do we need? Let me see if the pick fits in there. Take the pick. It does fit in. Okay, let me extend from this side up until all the components can fit in properly, and then take it down a little bit here. Good. Now this is my choose. Make this layer change to be a board edge. This is the board edge, and then place all the component. Great. Now we have the space. Now they start placing them up inside. Now we're gonna have them just like that, just like on the schematic over there. On the schematic, they're like this. On this side you have the output, and then on the other side you have the input. This is where the switch is, and then this is where the output, the bulb is. Now going to the PCB, it's just like that. Okay. Now what we need to do, we can adjust the board edge to a perfect scale. Now we are going to mount our PCB onto our application, so we need to have holes to attach the PCB, so that we're gonna put some screw inside the holes and then attach it into whatever application that you're going to use it. So now if you want those round holes paired, go here. If you want like this one, there's like a square, you just choose here. All these are holes, so I'm going to choose like from this list one bigger one. I think M2 or M3 will be fine. Just took M2, then place it somewhere here. Place this one here, and place this one up there, and done. Now, nope. You can go back to the selection mode and then change the length of this. Then put it there. Good. So now all the comments are inside. So now once you're done, remember to make sure that this edge board, this is a board, it must be not a layer, but it must be a board edge, not the top or bottom copper or anything, but just the edge board. Make sure it's like that. Now we have all these components inside. They are not connected to each other, right? You need to have them wires. But now if I can go and check into a 3D visualizer, I'm gonna have something like this. So this is my 3D visualizer of the PCB layout. It's going to be just like this on the bottom side, and then on the top side it's going to be like this. They are not threads, right? So all these components are not connected together. So if you want to have these components connected together, and then we have these holes that you're gonna use to attach your board into whatever application that you're going to use it to. And this is the microcontroller, and these resistors, transistor, and the diode. And then this side we have our crystal along with those two capacitor, right? So our circuit is complete here, but now we need to have them threads from one component to another. Go back to PCB layout. Now they are not threads, right? You can just like go straight to the track mode and take a wire from here and then drag it to whatever component that is connected to, right? From one component to another. We can do that, but that's going to take like forever. So what we can do, you can just go to tools, and now it's auto router. Now we are doing it automatically to place all those tracks. Do it like that, and then say begin. Change to just don't change anything there. Just begin the auto router. Now the auto router is done. Everything is complete. You see. So now we have this no CRC and then no DRC. So now this is a design rule status here. It's a design rule checker. Now on this side we have a connectivity rule checker. So the connectivity is perfect, there is no mistake, and the design is also good, so there is no mistake. So when there's a mistake, it's going to tell you right down here and right down, and then you go click on the mistake. It takes you straight to where the mistake is, so that you'll be able to fix it. Now this is the PCB layout. It's done, and we have all these tracks from one component to another. Then you can go check the visualizer and see if you have them component right underneath. They must be all underneath where you're going to do the soldering. Okay, let me move it. Okay, they're not here. Now let's go back and see where we made a mistake, and we must have the top part, and the red ones must be the top, and then the bottom and the top, the bottom and the top, the copper and the top. Great. And then let me cancel the visualizer and then do it again. There you go. So now you have them. See all those tracks there is, from the transistor to the resistor, from the transistor to J2, which is it's a light bulb, and you see we have some underneath, because this is where you're going to do the soldering part, so they must be right underneath. So you're going to be doing the soldering on this side. This is where you see them tracks. So you see this track from this pin of the microcontroller. All these tracks are in right below or underneath the board. So then the circuit is complete and everything is perfect. Now you're done. You can then save your